I am D. Anjireddy, Head of the Department of Computer Science and Engineering, Vageshwari College of Engineering, Karimnagar. Vageshwari College of Engineering was established in the year 2005 by the management of Sri Vageshwari Educational Society under the eminent leadership of Dr. G. Srinivas Reddy Garu. Ever since, our college has been committed to its quality education in policy. It has developed a state-of-the-art infrastructure in these 15 years and moving ahead of so many other colleges in this northern Telangana region. And now I would like to introduce you all of our today eminent speaker and the resource person, Sri Mr. D. Naveen Kumar sir. Sir is an assistant professor of Department of Computer Science and Engineering, KITS Warangal. With these few words, now I request our speaker to begin the session. Thank you.
Yeah. Good morning, all. Is my voice audible, sir? Is it clear?
Yes, sir. You are very clear. Please carry on.
Yeah. So these are the topics for today's session. We'll look at what are the basics of the cryptography and the history behind blockchain, or the foundation technologies behind blockchain, and the basic terminology we use in blockchain like node, block, miners, nodes, Merkle tree, and consensus algorithms, and so on. We will look at. And next, architecture of Bitcoin blockchain. And next is the algorithm, consensus algorithm proof of work we will see. And drawbacks of the Bitcoin blockchain. And we'll also look at the different types of blockchain. And next we will look at the Bitcoin scripting language. And we will look at a few use cases of blockchain. So here we go with the primitives of cryptography. So these are the things we use in blockchain. These are the cryptographic primitives like a hash function, public key cryptography, and digital signature. First we will look at these and we'll go with the blockchain concepts. So these are the cryptographic primitives we use in blockchain. When you look at the digital signature and public key cryptography, we use in initiation and broadcasting of transaction and proof of work and validation of transaction, the hash function, like chaining of blocks. So first we'll start with hash. So what is a hash? So hash is a function, a program which takes some plain text as an input, and we have this a plain text, high is a plain text we give as an input to a hash algorithm. Example hash algorithm is the SHA-256 algorithm, secure hash algorithm, and the output we have is a hash value which is a hexadecimal. Here you see is a numbers, only plain numbers, but it is a hexadecimal, a combination of digits and alphabets. And the hash is a one way, that is we can get back the plain text from the hash. So it's like from the plain text we will generate hash value, but the thing is the reverse cannot be done. So reverse is not possible. It takes it's not possible. So this is the hash generation. So these are the sample examples. Given the text, hi, I'm Sam. This is a hexadecimal format, hash value, and these are 256 bit length. Bit is nothing but is zeros and ones combination. So on we have 256 bit combination. When converted to hexadecimal, this is the hash value. Around it will be a 64 characters with some prefixes added. So the specialty of hash value, if you change a single character, like if you make this M has a capital, the entire hash value changes. If I add a semicolon at the end, the entire hash value added, entire hash value changes, and so on. These are the examples. Given the plain text, these are the plain text to the hash value. These are the hash, the output we have. So where do we use this hash value in real time? It's like, for example, if you take Gmail, during registration, when you enter all your details like name, email ID, password, and so on, your password is not stored as it is in a plain text. It is converted into your plain text. For example, the password, whatever you enter QW12, it is not directly stored in database. It's like it is stored, it is converted into hash. That is, it is given as input to the hash algorithm, and whatever output we get, the hash is stored into the database. So when you try to log in, after registration, when you try to log in with your password is first converted into hash, and it is compared with the already existing hash in the database. If they match, then your login will be successful. So that's why you will be having a reset option, but your password will not be displayed when you try forgot password. Okay. And this is the hash, and next is next cryptographic primitive is public key cryptography. We already know that we have two types of keys, like public and private key. And private key is it's secure, that is secret key with us, and the public key is known to all. So when we take a this is a private key can be something like a random number from which we generate the public key, and the reverse is near to impossible. Like the reverse cannot be done from public to private key. It's very less chances. Like it's like if it will take almost 4 into 31 or 10 to the power of 31 years if you want to reverse this one. So it's not possible with the current computing resources. So in the Bitcoin blockchain, it's like from the private key, we can generate the public key, and from the public key, we generate the address, the Bitcoin address. This is a Bitcoin address. So it's like from the public is hashed, and it is converted to a format, base 58 format, and we get is the Bitcoin address. So we'll see these are the algorithms. What are the algorithms used? Like from the private key, which is a 256-bit, it is converted into public key, and for this conversion, the algorithm used is elliptic curve digital signature algorithm. This is in the Bitcoin. On the private key, it's a random number. We can generate the public key using this algorithm, and from the public key, it is hashed. To get the Bitcoin address, the public key is hashed with this algorithm, RIP-EMD160, which generates 160-bit hash. So this will become the public key, and it is converted. This is the public key, and it is converted into 160-bit hash, and this is it is converted into certain format with base 58, and at the end we have its Bitcoin address. So here we have the private key. Here we have public key, and at the end we have is the Bitcoin address. So the algorithms used for private to public key is elliptic curve digital signature algorithm, and the public key to Bitcoin address is the hash, that is the RIP-EMD160, and also the base 58 conversion. Okay, where do we use this public key and private key? It's like private key we use for authentication by using digital signature. So it's like any transaction or any data we send from sender to receiver, it is digitally signed and sent to the other side. So the digital signature is done with the private key, and the recipient receives the message, digitally signed message, and he can verify the sender's identity with public key. So here is the usage of public and private key. From the sender side, the sender takes the plain text message or maybe a file, and he will hash it, and he will get the hash here. This is a hash. So here he may use the hash algorithm, something like the SHA-256 algorithm, secure hash algorithm, and he will get the hash, and this hash is encrypted with a private key. we get is digital signature. This at the end we have is a digital signature. So this is the first step the sender do. What he has done is using the private key, he had signed this document and he got digital signature here. Okay, so it's something like the fingerprint of this document. And next what we do is the sender, he will concat the plain text or the document, the digital signature, and also public key. These three he will send to the receiver or transmit to the network to send to the receiver. So these three he will do: the plain text, the the signature, and the public key. So this public key is used at the receiver to verify that sender is authentic, genuine. So this happens at the receiver. How you verify is the received plain text, he will hash using SHA-256 algorithm. He gets hash code here. He got the hash code here. And next is whatever digital signature he receives, he decrypts with the public key. This is the public key. So when he decrypts with the public key, he gets his hash here. So output of this step is hash and this step is hash. He compares both. If both are equal, then it's like the sender is authentic and message is not tampered during transmission. Okay. So actually they assume these two are different. So I said like this one. So these two hash are equal. It's like a successful authentication. Right. Next is we are done with the primitives of cryptography. We had the same SHA, that is hash algorithm, public key cryptography, and digital signature. And also we had seen how digital signature is used at the sender side to sign and the receiver side to verify. Next we look at the history of blockchain. These are the foundation behind the blockchain. You can see in 1977, it's like RSA is developed, RSA algorithm. You already know it's a public key cryptography algorithm. In 1978, the consensus algorithm, something like an agreement algorithm, and so on. You can see various developments. In 1996, it's proof of work, and 2002, it's a P2P, something like distributed. So P2P currency. These are the developments behind blockchain. So first we will look at what are the various issues in current banking, because we have a solution in blockchain on these problems, on these issues. So when you look at the issues with the current banking, it's like the first one is high transaction rate. For example, two persons who want to transfer some money, the middleman we have is a bank. So this person, when he transmits something like $200, he will get the lady receives only $195. Then the $5 will be the transaction fee. Even I experienced this type of transaction fee, like during the international wire transfer. The remittance charges are around 10%, 8 to 10%. I think most of you also experience the same high remittance charges during international transfers. Okay, and hacking, even there are the hacking scenarios, situations wherein ATM frauds happen. You can see the statistics in 2017, it's like 1785 frauds, and each of value 1 lakh. And next, the problem is double spending. So this is a problem. Generally, it used to happen before Bitcoin in digital currency. So what is this double spending is, the lady, the balance she has is $800, and she tries to send $500 to person X, And actually the balance she has is only $300. But thing is, she tries to send $5 to this one also. This is a problem used to be in digital currency before invention of development of Bitcoin. So this double spending problem is solved in Bitcoin blockchain. And even the last, the other issue, we have other issues, but this one, the fourth issue is something like we cannot trust the middleman, example, banks. So it's like we had seen some situations like wherein banks like S Bank, they flow away with the people money during the times of crisis. Actually, this happened in 2008 in US. It's like many banks got closed and they flow with the money, people's money. So this is the year 2008, wherein the developer of Bitcoin blockchain, Satoshi Nakamoto, he had released the white paper on Bitcoin blockchain. So we can say this is an alternative. Bitcoin is an alternative for these to solve these issues. So solution for all this is Bitcoin blockchain. So we can assume this Bitcoin blockchain like a network and also a database. Network like distributed network and something like a distributed database which stores data, and data is in terms of transactions. So this data, whatever stored, it is stored as a ledger. That is ledger, it is set of transactions. We'll see what is also a transaction. And when I say the distributed network, it's like these are different types of various topologies of network. It's like there's a centralized network. There is these are the various peers, and there's a central server. This is a point of failure. This one. And this is a decentralized network where we have sub-servers. These are point of failure. And this is a distributed network where all the peers are in equal status, no master slave. So there is no single point of failure. This is a distributed network where the blockchain users, or we can specifically even you can say Bitcoin blockchain users, this distributed network wherein all peers are equal, no server client or no master slave type of a relation between these nodes. So these are the different nodes, the circular ones, all of these are nodes. And a node in a Bitcoin blockchain or any other blockchain, it's like a node is one which can communicate with a blockchain, which can transact with a blockchain. We call it a node, and node can be any device which can transact with the blockchain. So this is a definition of blockchain. It's like blockchain is a immutable time-stamped series. That is, immutable means the records, whatever we stored in blockchain cannot be tampered, or we can say we cannot alter. And every data stored in blockchain has a timestamp. We know when it is entered into the blockchain. And it is a distributed ledger. That is, a ledger is nothing but a contains a set of transactions, and this ledger is stored in every node on a blockchain, and that is verifiable. That is, in Bitcoin blockchain, everything is transparent, and every transaction is verified by all the nodes. And the data, once recorded on a blockchain, cannot be altered without alteration of subsequent blocks, because there is a linking process in blockchain. So obviously we cannot alter without altering the subsequent blocks. This we will see in coming slides. What is this alteration without alteration of all subsequent blocks? Okay. So these are a few properties of a blockchain, like it is a immutable, that is cannot be altered, timestamped, has a date, transparent, anyone can view, especially Bitcoin blockchain, and verified transactions is verified by each of the node in the blockchain, and yeah, it's immutable. It's the same thing, immutable. Yeah. So we'll look at the Bitcoin blockchain. The question is, when we say blockchain, why people discuss about Bitcoin specifically, not some other thing? It's like So the reason is Bitcoin is the first blockchain ever developed, and it is a successful, $1 billion market. And most of the Bitcoin concepts are based for all other blockchains which came later. So this is the first blockchain. Bitcoin is the first blockchain, and it has inspired many other applications. So when we learn Bitcoin architecture, it's like all other blockchains are some variations of the existing blockchains. And this is a person, actually Satoshi Nakamoto. He's actually his identity is not known, but the white paper he had released on which he had specified the name is Satoshi Nakamoto, and he's a person. So there may be a person or group of persons behind, we don't know, but actually the identity of the developer is not known. But as per the paper, we know that the person is Satoshi Nakamoto, and this is the Bitcoin white paper which is released in 2008 October 31st. And you can see the title we have is Bitcoin, a peer-to-peer electronic cash system. The author is Satoshi Nakamoto. So by this we know, but actually his identity, true identity, we don't know. Pseudonym we can say. And he registered a website, this one, developed Bitcoin the same year, 2008, bitcoin.org. It still exists. And if you interested to view the white paper, this is a link. I will provide the link later. So you can see this one, bitcoin.org and bitcoin.pdf, a peer-to-peer electronic cash system. So this one is something like digital currency, a solution for the banking problems. So this is some history, like in 2008, he released published the paper, and he registered with the domain name bitcoin.org, published the paper in October 31st. And this happened in 2008. And in 2009, he implemented that published paper with establishing the Genesis block. So this is the first block, first block in a blockchain we call as Genesis block. So he started Genesis block in 2009, and the version of Bitcoin is this one. And these are the things in 2000 happened. Okay. So I say, like in Bitcoin blockchain, it's like we store data, and in Bitcoin blockchain specifically, the data is called a transaction. Remember, when I say data, you can assume it has a transaction. But what is a transaction? So transaction, this is an example transaction wherein we have the Bella transferring some $30 to John. So Bella is the sender, John is the receiver, and this is the amount which is being transmitted. So generally, it's like in blockchain, instead of the names, we have addresses. So address we have just seen, like from the private key we got public key, from the public key we got his address. So that address is used here. The Bella's address, John address, and Bella transferred John the $30. So sender's address, receiver's, and the transaction amount is $30. So this one we call as a transaction. So this transaction is stored in a blockchain. So this transaction, where do we get this transaction from? So this, if we assume this is something like a Bitcoin network, here we have a sender and here we have a receiver. And when a sender tries to send some Bitcoin, 1.20 Bitcoin to receiver, this is a transaction, we can say. Here Bella, here we can assume this is Bella and this is John, and Bella is transmitting $1.2 Bitcoins to receiver. So Bella to John, $1.2. This is one transaction. So it's like many other systems can send Bitcoins between them, and there may be many such transactions. So such transactions we can keep something like in a ledger. So here you can see there are various transactions here. This we call as a ledger. So you can say here, if we assume this is a network, it's like we have 4 people. The first, this lady named Bella, John, Elsa, and Jack. Bella has a a current balance of $40. She transmits $30 to John, and John transmits $20 to Elsa, and Elsa transfers $10 to Jack. So the entire transaction is like, say, Bella $40. The balance she has, she transmits to John $30, John to Elsa $20, Elsa to Jack it's $10. So this is a ledger, but in this scenario, it's like this is a central ledger, a traditional one wherein we have one server and we have the ledger, central ledger store. This data is stored in that server. This is a point of failure because the server fails, the entire data gets corrupted or we lose the entire data. So what happens in the blockchain is, the interesting thing is, this ledger is stored at all these nodes. This ledger is maintained by Bella, John, Elsa, and Jack. So here you can see in this diagram, this ledger is maintained by Ella, John, Elsa. It's the same ledger, Jack. This happens in the blockchain. Specifically, we can say it happens in the Bitcoin blockchain. Okay. Hope no confusion here. Bella, John, these four members, everyone has the same ledger. Okay. So where do we store this ledger? And what is the data structure we use to store this ledger? Because here we have only four transactions. There may be something like 1,000 of transactions. Do we have any tables type of structure? What is the structure we have? So here it's like we fill, if we have 1,000 transactions, we can fill in something like a bucket, or we can like a basket. In basket, for example, I have 1,000 books. What I do, or for example, I have 10 books. What I say, I will fill 3 books in a first basket, another 3 books in second basket, and other 4 books in the third basket. So I can fill in this way because based on the basket capacity. So in real time, if you look at this transaction, if I have 1,000 transactions, how do I fill? So here we have data structure like a block, a single block, wherein we can store this transaction, multiple transactions. So in Bitcoin blockchain, when we take a block, we can store around 2,000, 3,000 transactions in single block. If the block gets, so there is a practical limit of 2 MB, only 2 MB in Bitcoin blockchain. We can store only 2 MB of data in a single block. And theoretically, there is a limit of 4 MB, but practically it's 2 MB of data. So it comes around 2,000 to 3,000 transactions. We can still fill in single block. So once, if I have, for example, 5,000 transactions, so I fill 2,500 transactions here, and next to maybe 2,000, 3,000 transactions, second block, and so on, transactions gets filled. And I already said, like, these transactions are how they are generated when a user sends some Bitcoin to another user. So you can see these are the 3 blocks. They are some interconnected, and each block may contain a certain number of transactions. For example, the first bit block may contain 2,000 transactions. Second block may contain maybe 3,000 transactions. Third block may contain 4,000 transactions. Based on it's like that transaction size also. It varies, but each block has the same capacity, like a limit of 2 MB. Okay. So, okay. So what is the next question is something like what a block consists of in addition to the data, or we are calling it as a transaction also. In addition to transaction, what else a block contains? So we have it need to store some other information in addition to data or transaction, and how these multiple blocks are connected. So we look at answers for these questions in the next slides. First of all, we'll go to look at what additionally, in addition to data, what exactly a block consists of. So a block consists of, in addition to data, it will consist of hash of the previous block. This is an important thing. It contains hash of this block and also hash of the previous block. Because if it is a second block, it contains its own hash and also hash of the first block. Okay, and it also contains a Markle tree, and it also contains the Markle root. So this Markle root is nothing but it is the final hash generated from all the transactions. So the Markle root is also stored and Markle tree is also stored in a single block. And how this block, second question is how these blocks are connected, interconnected. So blocks are connected with the hash. So if you remember our subject like data structure, specifically the topic is linked list. In linked list, it's like one node interconnects with another node. How it is done is a node contains a pointer which points to the second node, the other node, next node. Okay. So first node, so in the linked list, it's like one node pointing to other node with the help of pointer. Okay. So this one is a distributed system. The pointer concept will not work. We'll go with the linking is hash. So for every block, a hash is generated, a hexadecimal. This is a fingerprint, something like a fingerprint for the block. And this is how the linking is done. So this is the first block. And I said the first block we call as a genesis block. And the first block's hash is this one. So actually we had specified in 4, but it is not. It's a hexadecimal format. Around 64 hexadecimal characters will be there in the hash. And this is the hash of the first block, this one. And what is the previous block hash? We don't, before the genesis block, we don't have any previous block. So obviously the previous block hash will be all zeros. All characters will be zeros. And next block hash is this one, 6pq1. And the previous hash of this block. So what is the previous hash we have is this one, 1z8. So this is the previous. So hash of this block is 6pq1 and the hash of previous block is 1z8f. And similarly, when you look at the third block, it's like this block hash is 3h4q and the previous hash which is stored in third block is a second block's hash which is 6pq. Okay. Hope it's clear. Yeah. Okay. So this one, the link, a chain of blocks which are linked with the help of hash. So we have here 3 blocks, but there may be any number of blocks. Currently in Bitcoin blockchain, we have around 6 lakhs, 8 lakhs plus blocks we have linked in this way. And this chain will be maintained by all the nodes in the blockchain. So you can see in my blockchain, I have 4 nodes and each node has the entire copy of blockchain. So entire copy. But the main problem is how these blocks are synchronized so that all will be maintained the same blockchain. The chain of blocks we call as a blockchain. Yeah, so before looking at that point here, you can see in this single copy of a blockchain maintained by a single node, what happens when I change a transaction in a block. So as we know, in a single block, we may have thousands of transactions. If I change one transaction, what happens? The hash changes, the hash of this block changes. And obviously, as we know, that this hash is actually stored in third block. So the link breaks. So when we change, it's like the link breaks and this entire block chain gets validated at specific node. At whatever node this modification is done with a malicious node, it's like the entire blockchain copy is validated. You can see the same thing I printed with another set of diagram. It's like this is the first block, contains a block number, data, maybe some other Markle root hash, yeah. and previous hash 0, present hash this one, and similarly block number 2, the data and the previous and so on we have. Third block also it's the same, and it's like they are linked. You can see this hash is stored in the block 2, this hash is stored in this one. So here you can see it's changed. Actually, we need to have this one 03EA here, but thing is it is changed. So obviously this blockchain gets validated that particular node where change is made. So here you can see this node. So suppose this person has done that alteration in this block, in second block. So obviously his blockchain gets validated and he need to get the copy from all other nodes. So this gets validated and obviously he need to get a copy from other nodes. Okay. Okay. So, so you have all of you may have a question like the blockchain cannot be altered. Then what we do when we want to modify a particular transaction in future, which is done by mistake? How do we modify? Because we cannot modify. When it modifies, the entire blockchain gets invalidated. How do I can modify this particular transaction in a block? So the answer is you need to add the transaction in the next upcoming block. So any modifications need to be added at the whatever block which is being created at present. So something like in this way, the modification block 084 exchange it to Y. This modification need to be added, appended, but it cannot be altered in middle of a block. That is a block which is in middle. We cannot alter the transaction. It need to be added at the end of the upcoming block. Right? Okay. Next is when a block is when a new block arrives into Bitcoin blockchain, especially if we can say Bitcoin blockchain, it's like this block is added to appended to blockchain of all the peers. We can call them nodes or peers. So this block is added. You can say added here. It is this is a first diagram where block arrives, and it gets added to this blockchain, this one, and also this one. So you can see added one. So during addition, all this will verify the transactions also. All these nodes verify and they will add. But the question is, who will create this block and how this all will agree on this block and add to their blockchain? So there comes the consensus algorithm. So it's like the algorithm which helps these pairs to come to an agreement and add that new block. So the consensus algorithm used in a blockchain is proof of work consensus algorithm, and we have many other consensus algorithms like proof of stake, proof of concept, proof of deposit, and some proof of time, and so on algorithms we have. In Bitcoin blockchain specifically, we use this proof of work consensus algorithm. And what is proof of work? It's like the nodes in the blockchain, they do some work and they show that work has a proof to add a block created by them. So the nodes which create the node and add to the Bitcoin network, we call them as miners. So what these miners will do is they do some work, they solve a puzzle. The work is they solve a puzzle and they show the proof so that their block, their created block can be added to the blockchain. Okay. Yeah. So obviously the block is created by the miners and they solve a cryptographic puzzle. And this process of solving the cryptographic puzzle we call as mining. So miners mine, that is they solve a cryptographic puzzle, and when they are successful, they add the created block to the blockchain. and actually they broadcast that block to the all other nodes. So it's something like the miners, for example, there are a lot of transactions getting into the network because various users are transacting, sending some bitcoins. So there are 1,000 transactions. What miner do is he will gather all those transactions, he will verify, and he will store in a mempool. And next he pick up those transactions, construct a block until in Bitcoin blockchain until it reaches 2 MB. He puts all the transactions and he solves a puzzle. We will see what is this puzzle here. He calculates a hash. So the puzzle is something like he tries to generate the hash for the block. So that is the hash consists of maybe 5 or 6 zeros. It is specified by the Bitcoin protocol with the help of the difficulty target. So this is a proof of work hash algorithm which the miners will solve. So what they do is they take the block and the block contents they pass to a hash algorithm. And example, the Bitcoin network, it's a SHA-256 algorithm, and the output we get is a hash value. And the miner checks whether hash value contains maybe the target is it must start with 4 zeros. So he checks whether it starts with 4 zeros. If it is not, what he do is again he will change the nonce. So it's like every time he changes the nonce, he uses a brute force attack, or we can say brute force technique, wherein the nonce will be starting, he will keep 1, nonce is 1, he will pass entire block, the data previous block hash will be same. So he passes the entire block to the hash algorithm. Here the output we get is hash, and he checks whether the hash starts with 4 blocks. So no, my hash doesn't has any zeros, or it may have 1 or 2 zeros, but the target I want is 4 zeros at the starting of the hash. So what I do is I will change, as a miner, I will change the nonce, I will increment the nonce, it becomes 2. Again, he passes to hash 256 algorithm, he gets the output hash, he checks whether the hash contains starting 4 zeros. If it is not, I will increment nonce 3, increment the nonce, it becomes 3, again pass to hash, I'll check the hash, and so on. It repeats until he gets a hash which may start with 4 zeros or maybe 10 zeros, whatever the Bitcoin protocol specifies, and it changes every 4 years. That is after every 210,000 blocks, the difficulty level changes. No, it's not every 210 block. It changes every 2 weeks. We will discuss it in later slides. So this is a scenario. So every time he hashes whatever he get, and he will check. If it's not as per the target, he will go on implementing only the nonce. Right. So if he at the end, if he succeeded with the nonce of, for example, 21,000, he got the hash which starts with 4 zeros. So what he does is miner. Along with this block, the nonce also he appends, and he transmits this information, this block information to all the peers into the network. So this happens with the help of a gossip protocol. This block gets communicated to all the peers within few seconds. In Bitcoin network, it's like it happens around in 40 seconds. The 95% of nodes will see this new block. So it's like many miners will be trying to solve this puzzle. And remember, miner is, anyone can be miner in a Bitcoin blockchain. For example, I can be a miner, but what I need to have to be a miner? Any node can be a miner. So I need to have the full Bitcoin blockchain, that is full copy of blockchain, and the required software, and also the required hardware which can mine. So for this mining process, it's like Satoshi Nakamoto in 2009, he used just a simple desktop with normal processor, but as the time passes, the mining difficulty had increased a lot, so that the people started using graphic processing unit GPUs. And even at certain moment after as time passes, even GPUs are not able to do this mining process. So then came ASIC miners, application specific integrated circuits. So they are the hardware specifically designed to mine for the mining process. So for the Bitcoin mining, we have specific hardware ASIC miner. Like example, we have is Bitmain Ant miner. S9 version is the latest, which is around $8,000 currently. So for this mining process, it's like many miners try to even collaborate and try to mine, because they need a lot of computation power. There's some trillions of hashes per second. So all the miners join together and work. Even there are a lot of organizations, specifically most of the miners are there in China, and even the organizations, they group together, they get together form a pool and they try to mine. And in turn, these miners get a reward also. So the benefit of, they invest all this hardware and their time and lot of electricity consumption. Actually, China has a lot of miners because their electricity cost is very low. So a lot of people try, so even organizations form a pool and they try to mine. So these miners get a reward, something like, the reward is like 6.25 BTC current block reward. So the Bitcoin blockchain releases Bitcoins whenever the miner does a successful mining. The Bitcoin network releases some reward to him. It is currently 6.25. When in 2009 it was 50 Bitcoins. Every 4 years it halves, becomes half. So in 2009 it was 50 Bitcoins, and in 2012 it became 25 Bitcoins, and in 2016 it became 12.5, and last month the halved happened in May. Last month it happened, and the Bitcoin reward is 6.25. So the miner who mines this, does this puzzle, and who wins this lottery, we can say, he will get the 6.25 Bitcoins at present. And also he get the transaction fee also. If the block contains 1,000 transactions, each transaction has some fee, like 0.305 is the fee. Generally the exchanges apply. So for each transaction, there will be a transaction fee. If the 1,000 transaction, the entire aggregation of all the transaction fee will be given to the miner. So there will be a transaction fee plus the block reward of 6.25. Okay. So when the miner solves this block, he transmits the block to the network, Bitcoin network. It comes and it adds. So before adding, these people will verify all the transaction, whether the transactions are valid. So after verification, the successfully added using this proof of work, the puzzle, solving the puzzle. Okay, so this we already discussed just now. The miners use a lot of resources like time, money, electricity, lot of electricity. It's like Bitcoin network uses electricity of small states in worldwide. A lot of electricity is consumed because, and you can say that a lot of energy, the computing resources are wasted for this mining purpose. And this also we had discussed just now. Miners receive intensive, that is reward in form of a block reward. That is $6.25, 6.25 BTC, that is Bitcoin, short we call as a BTC. And transaction fee, something like around 0.305. So it also varies, the transaction fee also varies. Before the halving in the last month, transaction fee was around, in our money we can say it around 300-350 rupees, but at present it was below 100 rupees. So when as time passes, this block reward decreases. After 4 years, next 4 years, the 6.5 divided, becomes half, 3 point something, 3 point plus, it becomes BTC, it becomes block reward, and the block reward decreases and transaction fee increases. So, so still miners will work because they will be getting the increased transaction fee. So this one also we had discussed. Block reward is halved every 4 years. So it happened in first block halving happened in 2009, next 2012, 2016, and 2020 in last May, around in May 11 it happened. So it happens for approximately every 4 years or after every 210,000 blocks. So current blocks it's running is 8 blocks change. Okay. The average time of block formation is 10 minutes. So there will be, every new block will be added to the Bitcoin blockchain every 10 minutes. Okay. So it's like if I as a miner have lot of computing resources, I join with a lot of other people, and I increase, I update my hardware resource also with sophisticated hardware, and I join with all other persons and try to mine, then my block time can be 6 minutes, right? It may decrease. If some other person who doesn't have resources, his time can be 15 minutes, more 15 minutes. So if it, sometimes it may increase or decreases. So what interesting thing the Bitcoin blockchain does is, it adjusts the difficulty of solving this puzzle every 2 weeks, so that on average, the block will be mined within a time of 10 minutes, not less than 10 minutes, not greater than 10 minutes. So it adjusts. If, for example, in present 2 weeks, the to mine a block, it takes around 6 minutes. It's like it after 2 weeks, it adjusts the difficulty level so that it is only 10 minutes. Okay. So the difficulty of the puzzle increases or decreases depending on the time it takes to mine the blocks. The same thing. And one interesting thing is Bitcoin maximum supply is 21 million Bitcoins. So the total Bitcoins in this Bitcoin blockchain will be 21 million Bitcoins, and they will be released constantly when a miner solves the puzzle. So till now, the circulating supply, whatever Bitcoins are released from 2009 into the Bitcoin blockchain due to the mining is 18 million Bitcoins. And still we have other three, only left with 3 million Bitcoins. Okay, right. So as I said, every transaction is sent, packed into a block, and it's transmitted to other end, the sender to receiver. And recipient, it's like every transaction is digitally signed. Just now we had seen how digital sign is made. So every transaction is digitally signed, and it is sent to the other end. The recipient will can verify the transaction with the help of the public key. So this is the same thing I discussed just now, the starting during public key topic, the verification process. So every transaction is signed during transmission by the sender, and it is received at the receiver side. It is verified if that it is the sender is genuine sender and the data is not altered. So this is what happens in a blockchain. The entire what you say is something like an architecture type of thing. Generally, it's like as a first step, the transaction is requested because, like, I want to send some 5 BTC to some other person. That transaction is at miner side. It is copied into a block. A block is created with all the transactions, such transaction, and the block is mined. The hash is solved here, and it is sent to all the nodes in the network. All the nodes verify the transactions and add to their copy of blockchain. And the miners, so after miners will get the incentive of the BTC, the rewards only after verification addition of block to this blockchain. So after addition, it's like the miners will receive the reward for solving the puzzle, and so the addition is done, and after addition, it's like the transaction is complete. So after addition to the blockchain itself, the receiver gets the Bitcoin which is transferred by the sender. So one important thing is when a block is added to the blockchain, one block is added to the blockchain, we call it as one confirmation. So in online, there are some websites which are accepting Bitcoin. So those type of merchants, they accept, they will ship the goods, whatever products they are selling, they will ship only after 6 confirmation. That is, after 6 blocks are added to the blockchain. Okay, this is the same process with some other diagram handler, same architecture. Yeah. Next is Bitcoin scripting language. So it's like for the entire just now we had seen the verification process, like this part. This verification process, this entire verification, specifying of a public key and so on, this verification process and this signature, everything, this is specified in terms of with the help of Bitcoin scripting language. So Bitcoin script is, this one is a stack based. It is a stack based, and it's not Turing complete because it lacks the features of, it doesn't have a looping and some limitations. It is not Turing complete. It is simple and compact, and it is specially designed for cryptography. So this scripting language has some opcodes which are used to sign or to verify. We have some opcodes. These are list of opcodes we have in the Bitcoin scripting language: op2, op hash 160, op equal verify, op check sig. And as said, all these that is whatever data, the script, entire script codes, generally they are pushed, the data is pushed into stack, and we apply these opcodes. The op means it duplicates the top content of in a stack, and this hash 160 means it hashes the top content of the stack, and equal verify is it verifies, it checks whether the top 2 contents of a stack are equal, and checks the signature. It verifies the signature. We have a lot of opcodes. These are the sample opcodes. Yeah. And next is drawbacks in Bitcoin blockchain. So already we had seen, like the miners invest a lot of hardware resources and lot of electricity, and this is a huge wastage happens in Bitcoin blockchain. That's why we have many other blockchain which doesn't use this computing resources, this much computing resources. That's why we have a proof of stake and many other algorithms, consensus algorithms. And next is we have a threat to the Bitcoin blockchain, that is a 51% attack. That is, for example, in the Bitcoin blockchain, there are, for example, we have millions of nodes in a Bitcoin blockchain, but we assume we have only 100 nodes in a Bitcoin blockchain. So in 100 nodes in a Bitcoin blockchain, if 51%, that is more than 50 people gather together and use their computing resources, they can reverse the transaction in the Bitcoin blockchain. It is possible. But the computing resources required is a lot. It may require something like hundreds of thousands, hundreds of crores. It may require to do this 51% attack. So it is possible, but it requires a lot of computing resources. Okay. Next is types of a Bitcoin blockchain. So these are the different types of blockchains. We have public blockchain, private blockchain, consortium blockchain. So when you look at the public blockchain, It's like Bitcoin is an example of public blockchain wherein any node can join the blockchain, the network can join the network, no permission required, and the identity is not known. The sender and receiver are represented with the help of addresses. So the names are not revealed in the public blockchain. Anyone can join it, and anyone will, all the nodes will validate the transactions. Public blockchain example we have is Bitcoin, and it uses the consensus algorithm like proof of work and even proof of stake also. So Bitcoin is an example of public blockchain, and we have even Ethereum. Ethereum is also a public blockchain, and we have many other public blockchain. And we will discuss about Ethereum blockchain tomorrow. Next we have is private blockchain. A private blockchain, it needs permission. The identity of the users is known, and anyone with only permission, anyone can join into the this blockchain. And consortium blockchain is something like a hybrid of public and private, like a consortium group of organizations which belong to one particular authority. They can form a blockchain. A set of organizations like belonging to a Tata group, they can form a consortium blockchain, a combination of public and private blockchains. These are some features. The differentiation between public, private, and we have a consortium, or the other name we can call as a federated blockchain. So access is anyone can access. We have a private blockchain, a single organization, and here we have is multiple organizations in this consortium blockchain. As I said, multiple organizations of a maybe Tata group or any other organization. And the participants, no permissions is not required. Here we require permission, security, the consensus algorithm. And here we have is some voting mechanisms are used in private and federated consortium blockchain. These are the proof of work based in public. These are the consensus algorithm used. And transaction speed is slow in public blockchain, a little faster in this one and this one. So example of this blockchain, we can say like Hyperledger is an example of this blockchain, the consortium. And the transaction speed, when we take in Bitcoin blockchain, it's like for every second, it's like very slow. It's because for every 10 minutes, a block is mined. So obviously the transaction speed per second, on average, it gets around 5 seconds. Sorry, 5 transactions per second is the transaction speed of this Bitcoin blockchain. And in other blockchain, it's like when we take Hyperledger, which comes under consortium or this one private, it's like Hyperledger transaction speed is 3,500 transactions per second, around 2,500 to 3,500 transactions per second. When you take Ethereum blockchain, the transaction speed is 15 transactions per second. And actually, the Visa transaction, the digital payment system we use currently, its transaction speed is 55,000, 65,000, and actually it claims some lakhs of transactions per second processing a lot of transactions per second. So these blockchains need to be scaled and reach that speed to be used in our many of use cases. Okay, and when you look at the blockchain use cases, these finance sector, where do we use the blockchain? So in finance sector, we can use the Bitcoin blockchain. It is a block, so it's something like a Bitcoin blockchain. It is something like a currency which can be used, something like $1 worldwide. It can be used. Next is in education sector. It's like the blockchain can be used to store certificates in a digital format, so that the certificates cannot be tampered or modified. And in different organization, government can use this blockchain. For example, Estonia government. Estonia is a small country which is using the blockchain for its in its government organizations to be transparent for the entire public. we'll look at that scenario in tomorrow's session about the Estonian government. They use the KSI blockchain. So in taxation, it can be used to blockchain. In these are the few other cases we can use in land registry. That is whatever land records. We already know that there are a lot of frauds going on in the land registrations, like changing the authority, the holder of the person. Those type of frauds can be eliminated with the help of this blockchain usage, and even supply chain management. So it's supply chain management. It's like when we look at the products, it's like there will be a lot of intermediate persons who goes on processing the things, like farmers produce the grain and it is processed at some center. And some other organization does the packaging, and some other organization can be sending it to wholesaler, and at the end it may reach something like a retailer, something like a shop, normal shops. So there are this we call it supply chain management. So in this supply chain management, where there are various intermediaries, we can track with the help of a blockchain what happens, because at the end there is a problem with the quality of the product. So we'll look at this scenario in the tomorrow's session once, with the help of a Walmart having this blockchain in supply chain management. And even we can use it in health sector also to maintain the health records. Right. So these are a difference between various this blockchain types of blockchains. Public, we have a Bitcoin and Ethereum. We are already done with this part of discussion. Yeah. So now what we will do is we will see some demo type of thing. So we will see with the help of a browser, we will see how this hash is generated. If possible, all of you can try this part. Yeah. So this hash creation, it's like I said, like a plain text is given to the hash algorithm like SHA-256, and we get is the hash value, which is hexadecimal format. So for this type of conversion, we have a simulation in a browser, some demo type of thing. I will show it. I will keep the link also. I will post the link in your chat box so that you can also try once. Let me share that how the hash can be generated given the plain text. Something like a practical type of thing. Able to view this one, download Bitcoin Core. So, Siraj sir?
Yes, sir. Yes, it is visible, sir.
Yeah. So actually this Bitcoin Core, if you, as I said, like in Bitcoin blockchain, you can there are a lot of nodes in Bitcoin blockchain. That node can be full nodes, or we can say partial type of nodes. So when you say full node, they need to have entire copy of blockchain. If you want to be if you want to be a full node, you can download. This is the link, bitcoin.org, where you have a .exe, like based on operating system, like for Windows or Mac or Linux, you can download this Bitcoin software, which is for Windows, it's like 14 MB software where you can download and you can install. And this this software will download the entire copy of blockchain till date, starting from 2009. So it asks for a minimum requirement of 200 GB capacity of a hard disk, and this Bitcoin port, the Bitcoin, it runs on the port 8333. So if you require, if you want, you can download this one. I will paste this link in your chat. Okay, and yeah, so if you want to a full node, it's like you can download the, if you have an entire copy of blockchain, you call as a full node. And the partial node, it's like if you want to, don't want to have the entire copy of blockchain, if you want just to interact with the blockchain, you can, we have a browser plugins like MetaMask, or maybe you can download even wallet also. Okay, so if you want to store a Bitcoin, there are a lot of wallets, like we can call as hot wallets or cold wallets. Cold wallets is like paper. Paper wallet is a cold wallet, and even we have a hardware devices like Ledger, Ledger Nano S, and Trezor. Ledger Nano S hardware wallets, and we have a lot of software that is those are cold wallets, and we have hot wallets like. I will show an example of hot wallet also. It's a browser-based wallet, can be, or maybe a desktop software. So as I said, like we will look at the hash demo. So this is a source code. If you want Bitcoin blockchain entire source code, you can go where there are multiple versions of Bitcoin source code, because as a source code, everything is available in the GitHub. So you can have this link also. Yeah, so this is a demo I want to show. Let me. All of you try to open this link, andersbrownworth.com. Try to open in your browser like Chrome or Mozilla or any other browser. And you can see here the hash is generated, whatever content, whatever text or message you type here. For example, name like hello. So for this hello, SHA-256 algorithm is applied, and you can see this is the hash generated. So okay, this one is clear. So if I change a single letter, it's like the entire characters of this hash get changed. So for example, I make it capital. The O has a capital. So it's a small letter. I made it a capital. You can see the entire hash changed. All the characters of the hash change. If I add a character like 1, you can see the entire hash changes. So this is a SHA-256. It is a program which takes the text, any message, and it gives the output is a hash. And the hash is a hexadecimal format which contains the numbers from 0 to 9 and alphabets A to F. And you can see the hash changes when I go on typing and so on. And interesting part of this algorithm is like whatever message length, any variable message length, the output hash will be the fixed length. It will not change. It will not increase or decrease. It will be the same. Hash will be the same. So you can see it's a small message or maybe a bigger one. It's the same. Okay. So I can try this one. And okay, this one with the hash. And next we will see the this is a demo on public key cryptography. This is a demo on public key cryptography. So when you look at our slide, something like so we are done with the hash we had seen, and next is public key cryptography. So this verification, so as I said, like given the plain text, we calculate the hash, and whatever hash we have, it is encrypted with a private key and we get the digital signature. So plain text is hashed and it is signed with the private key, and we have at the end his digital signature. So, and later this data, the digital signature with the plain text and the public key, they are transmitted into the network, and with the verification is done here. So this part we can show, we can see in this demo. This. Private key is maybe a randomly generated, and when you pick this random, it's like a randomly a number is generated, a private generated here. And the private key, public key is typically, so internally they are using the algorithms. So random key from the private key, the public key is generated, and so here at the top you try to click these keys and you will get this page. So let me copy this link also, your chart. So if you all of you can open this link and try to check. So a random number, you can click random number is generated randomly from the private key, public key is derived. So make sure that you click this one, this link, keys link to the top right. So now I have the private and public key. So what I can do is I can sign my plain text with the private key, and as a sender I send that they sign the plain text to the other end, and receiver will verify with the public key. So this one we can check with this part. If you're done with this one, we can go with it. This one. So the whatever we had done, the signing the text and sent by sender, and it is verified the receiver. This we can do in this link. Let me click this one, signatures. Okay. So you can see, for example, any message can be signed with the private key. So as I done in the slide, shown in the slide, it's like I can type a plain, this is my plain message, a message, or can be the file with a lot of content. It will be signed with the private key. So for the signing, I said like the plain message is converted into hash and it is encrypted with this private key. And we get is the digital signature. Okay. So when I click sign, this Naveen, the plain text message is signed with this private key. And this happens at the sender side. So what sender will do is the plain message encrypted with the private key, that is signing with the private key. And here we have is the digital signature. Okay. And as a sender, what I do is I will send broadcast, I will send this plain text message, the digital signature, and also the public key. Private key I will not send, it will be with me, it is secret key. So what I will send is the message, the signature, and also public key. The three I will send to the receiver. So what will receiver will do, he is with the help of the public key, he tries to verify. So what during verification at the receiver, this happens at the receiver side. The receiver will be having the message, he will be having the public key, and he will be having the digital signature. Okay. So what we had just seen how the verification is done. If both the hashes are same, then it's said like the data is sent by authenticated person. So the verification is something like when you click this verify. So this public key is used to verify the signature. So when we click verify, if you get the blue colored window, it's like verification is successful. If we get a red type of window, a different one, for example, I modify this one and try to verify. I change the message and I try to verify. You can see it's not successful because I had changed the message. Similarly, if you change the public key also, it's the same colored window we have. If you change the signature also, it says it's wrong. So you can see when I say Naveen and when I say verify, it's a blue window, successful. Verification is successful because the message is not altered, the public key is good enough, and the signature is also not altered. Okay. So once you can try with this part. Next is go with the transaction part. You're done with this one. So instead of plain message, you can say a transaction from this address. We are sending this to this address, and the transaction amount is $20. And this is the actual message. Message will be in this form in the Bitcoin blockchain. So it's signed with the private key. We'll sign, and I get his digital signature. Okay, this is the same thing we had done in the previous one, the signature part, but here instead of plain message, we are using a transaction type of thing, which one will be in the Bitcoin blockchain. So this transaction I'm signing with the private key, and I got is the digital signature. So I will send this the transaction plus the digital signature plus public key I will send to the receiver, and the receiver can verify with the public key. So the transaction, we have the signature, and we assume we have a public key also, the receiver and we say verify. It's a blue window. Yeah, everything is fine. It's verified. So all of you once go through this and try. Meanwhile, we'll show other thing. Go through each of the link and check once. Signing and verification. And one important thing, yeah. So these are in real time what a block consists of. So we can say it's a blockchain explorer, like Windows File Explorer. It's like you can say it's a blockchain explorer where we can see real-time data, what a block consists of. And this is data about first block. So first block is called block 0. So I'm posting in this chat window. Please all of you go through this. Try to open this link, blockchain.com, BTC block 0. Sir, is the message being delivered to all the participants? Oh, I'm sorry.
Sir, just post in chat box. It will go to all participants, and make sure that you have in 2 sessions you have everyone.
Yeah. So actually, I'm posting on particular participants. Okay, let me post this link to this one.
Yeah, it is visible, sir. It is visible in chat box.
What about previous links?
No, sir, we don't got any previous links.
Yeah. Actually, no one responded, so we thought everything is fine. Yeah, I will send. Yeah, no problem. We have enough time. Let me post all the links. Right. So this is the first one.
Yes, sir. This is the first one.
Yeah. This is the first one. Hash. AndersBrownworth.com blockchain hash. Wait. Changing to a particular participants. Everyone in meeting. Yeah. This one is okay. Everyone received. It's at the end of the link. You can see the hash, the word hash. Yeah. So this is a link wherein you can check. Okay, I will repeat once again. So you can see, you can type any message, hello, and check how the hash changes when you make it a capital or any other letter capital. It's like the entire hash gets changed. All of you open this hash link and check once. You're done. We'll go with the other one. Let me post other link also. The public-private key verification using public and private key. Yeah, this is a message which shows a demo of public and private key, where the message is You can see the transaction, a single transaction or normal message. You can see how the transaction is signed with private key, how it is verified. Try to change yeah. So try to change any transaction. I can change transaction to maybe $10. $10. Yeah. Yeah. Signing part, it's okay. You can sign it. But during verification, if I change, it will be a problem. During verification, it says no. Something is altered. I changed the message. The transaction amount to $10 to $5. So go through this part. Meanwhile, I will another link. Okay. Next, of you try to open this link. Okay, all of you try to open this blockchain explorer, blockchain.com BTC block 0. Try to click the link and it gets open. So blockchain.com. So it's a blockchain explorer where you can see the real-time block information. Blockchain.com BTC block 0. Hope all of you open this link. Yeah, this is a real-time information wherein this is a first block created by Nakamoto Satoshi, the inventor of Bitcoin blockchain. That's why the first block number we have is block 0, and this is a hash of the block. You can see the number of zeros around it's 3, 3, 3, and it's on 10, 11 zeros we have. 10 zeros we have. It's like they used to use normal desktops and try to generate this hash. Not much computing resources required at that moment in 2009. And you can see the number of confirmations. So after the block for each block addition we call as a one confirmation. So till now these are the number of blocks. It's like so these are number of confirmations got added, and these are timestamp when the block is created. It's 2009. These are timestamp. The time which is created. The height of the block is 0 because the first block, and minor is unknown. And number of transactions in this block is only one transaction, and difficulty level is the target which specifies how difficult to generate this hash is 1. And this Markle root is the entire the single hash generated from all the transactions. So this Markle root is like, for example, a block contains maybe 2000 transactions. All these 2000 transactions are made as pairs. We get around 1000 pairs. So these two, all these get into these two pairs get into a hash algorithm, and whatever we get out, they are hashed, and so on, so on. The process continues until at the end we get only single hash. We call it as a Markle root hash. And this is a Bitcoin version. This is the number of total bits we have, the weight of the block. This is a WU, weight unit, means weight units, the size of the block in bytes, and this is the nonce. So miners try to generate the nonce, try to modify the nonce starting from 1. They try, or we can, based on hardware, then we can be a random nonce also. The hardware can try for with a random nonce also, so that this hash is generated at the end. So every time the nonce will be starting from 1, they apply brute force technique and try to apply SHA-256 algorithm, replacing nonce every time, and try to get the hash. So if the hash he gets is this number of zeros as per the difficulty level mentioned here, it's like the miner is successful. Okay, and the block reward he got is 50 BTC, 50 Bitcoin. So whatever rewards we get, those will be entered into circulating supply of Bitcoin. Okay. And one more interesting thing we see is a demo of how the mining is done. Yeah. Yeah, blockchain demo. Are you able to do this one, blockchain demo? Okay, let me paste this link also in the chat window. Yeah, blockchain. Sir, able to view this window, sir?
Yes, sir.
Yes. So these are blockchain demo, andersbronworth.com /blockchain/block. So this is a demo of how a block will be. So it's like, just we have seen like a block contains block number. Actually, this need to be first block, Genesis block need to be 0. The first block we call as a Genesis block, which will be a 0 block, and the nonce any number, and this will be a 32-bit number generally it's like, and any message, any message, right? And we need to generate a hash. So we need to mine this data. This is a block information. We have a block number, we have a nonce. Like for example, the person may start from a brute force attack. He will start with 1. The miner will start with 1. The data will be as it is. And he tries to generate, by mining, he will try to generate a hash, which the target is the hash must start with 4 zeros. So he tries with 1, clicks the mine button and checks whether hash has 4 zeros. No. Then he will change the nonce to 2, and again he will. So even this block contains the Markle root also, which is not specified here, and he will click the mine button, and he will check whether the hash starts with 4 zeros. No. So he will make it 3, and he will click mine button, and he will check whether 4 zeros are there. If 4 zeros are there, he is successful. He will stop mining. So he goes on trying various numbers, 4, 5, and so on. He tries, and at some point he gets a hash which starts with 4 zeros. For example, we will try directly. This program directly gives us the hash which starts with 4 zeros. Okay, that's why I'm not clicking this button. So when I click, you can see the nonce changes. So it generates a nonce which it finds a nonce which generates a hash which starts with 4 zeros. So you can see it's mining, trying all the nonces. Yeah, I got this number. So this, for this message, it's like this is a, for the entire block, you can say this is a nonce which generated this hash wherein it starts with 4 zeros. 1, 2, 3, yeah, 4 zeros. Okay. So for every block, it's like the nonce is found and which can generate the hash as per the difficulty level, maybe which starts with 4 zeros. And once successful, the miner will broadcast this block to entire network. And the nodes in other network also verifies whether this nonce is correct, whether it is generating this hash, and they check the transactions and they will add that block into their blockchain. So remember, we don't. This is the we can assume this is the first block. So there can be many other blocks. So we see another 2 blocks addition to this one in this second link. Make sure that you click this one, block part. Yeah, by default, when you click the link, this page gets open. And let me click this part, blockchain. Hope all of you in sync with me. Yeah. So this is a blockchain demo wherein we have a blockchain contains multiple blocks. This is a block, first block, this is a second block, third block. And remember, in reality, it's like this will be a 0, this will be a 1, this will be a 2. And in demo part, it's like they have mentioned like 1, 2, 3. And it's like any message. So you can see a block consists of block number, nonce, maybe he tries with 1 first, next message is kept, and the previous hash. So this is a hash of previous block, which is all zeros, and he need to calculate this hash, which must start with 4 zeros. So let's mine and see what nonce will generate a hash with 4 zeros. I had clicked this mine button, and it's mining, trying all the nonces which can generate the hash which starts with 4 zeros. Yeah, so this is the nonce I got. This is a nonce I got which generated the hash with 4 zeros. Okay, hope I want everyone to try this part. So for the first block, I had mined successfully as a miner. I'm done with mining first block. What I do is I broadcast this block. Automatically the software will do broadcasting this block. And next is I will go mining with second block. What I do is whatever transactions in my mempool, I take those transactions, fill in another block, like in a basket. I will fill the books, and I will try to mine. And if I am successful, every time I may not be successful. Some other miners may be successful. So there are many miners in the network. All will be mining the same. All will be mining with different set of transactions. Not maybe same set of transactions. There may be different set of transactions. But only at the end, one particular block gets added, and so on. Blocks gets added. So hope all of you done with this part, mining, and it's like when we take a. So again, I'm mining. I clicked. a mistake had made clicked. It's the same thing. We will be, nonce will be the same thing because the message is same. The contents are same of the block, right? So I try to mine this one. I keep some message like Raju, but in real time in blockchain, it will be transaction will be like Navin transferred some amount to maybe Raju $10. This will be in reality in Bitcoin blockchain. The transaction will be in this. I mean, the data will be like transaction, and this will be like in single block. Maybe something like Raju transferred maybe to Pawan maybe $5. Yeah, and so on transaction there can be, and he will mine. So there will be different nonce here. Yeah, these are nonce which generated. You can see the hash is 4. Still, it's a 4 zeros because the difficulty specified. The hash must be 4 zeros at the. All right. So maybe Raju transferred Mayur with $30. This is another transaction, and I try to mine. So this is not actually nonce, actual nonce. When you click this mine button, then nonce gets generated, which can have a hash which contains 4 zeros at the front, leading 4 zeros. Yeah. So here, this is my nonce, which generated a hash with the 4 zeros at the front. Okay. So second block, you can see the previous hash is the hash of the previous block. So the previous block, we can see the important thing is this one. Previous block hash is 4 zeros, E, double E, and 54. So here you can see 4 zeros, double E, 54, and so on. Previous hash. And this is the hash which is mined by miner. He is successful. He will release this block into the network and says to other nodes like, hey, I had found a block. Please once check and add this block to your blockchain copy. So as I said, one block is added. We say has one confirmation. So similarly, maybe some other thing like someone transferred some amount to Srikant, and it's $45, and I mine my third block. Right. So you can see here, block number is 3 because the third block, and the nonsense generated, which generates the hash which starts with 4 zeros, and previous hash is, you can see this one. The previous hash is hash of 4 zeros and 84A5, and this is the hash generator. So the blocks are linked with the hash. So every hash, every block consists of a hash of the previous block. So this block consists of a hash of previous block. This block consists of hash of previous block, and here this block consists hash of, we don't have any previous block, so obviously all the characters in the hash are zeros. Okay, and as I said, like every node in the blockchain contains a copy of the entire blockchain. Maybe lakhs of nodes, lakhs of blocks will be there. Here in the example, we have only 3 blocks chained with the hashing, and there is in a network there will be multiple nodes. The nodes can also be called as peers. So in distributed network, it's like we have multiple peers. So you can click this one, distributed network, distributed the link. So you can see these are distributed environment as a demo of distributed environment. We have a peer A. So I may be a peer A. I have my copy of blockchain with some data, maybe X, maybe Y here. I need to mine. So when I mine, I get is nonce. So in the same way, so there will be multiple peers. So you can see here, peer B, he may contain the blockchain. Block C, he is some other peer, maybe a person like named Srikanth, maybe peer C. He has his entire blockchain copy with him. He is also a miner, so he will be mining. So in a distributed network, it's like there will be all the nodes out of all the nodes, there will be few miners and there will be normal nodes. There can be miners, there can be full nodes that is containing the entire copy of blockchain, and there may be users or peers who can just or nodes who are just interacting with the blockchain. Okay, so every miner will be trying to mine. So as a miner, I am peer A, I will mine this block. I got the hash with 4 zeros. Next I go with, I will release this block into network, and the other peers, other peers also trying with this first block. But thing is, they receive the block from peer A. So what peer B do is, he stops mining. He takes this block what he received from the peer A, he checks it, verifies whether the nonce is correct, and he checks all the transactions, and he adds, and he goes with the next block mining. So a lot of miners will be trying to mine the blocks and broadcasting. So I may, as a miner, I may get a lot of blocks at the current containing of the recent transactions in last 10 minutes, maybe all the recent transactions I receive as a block. So I may receive all the multiple miners sending, they had solved the puzzle and they had broadcasted the blocks, and I will be receiving all the set of blocks. But thing is, I will accept only that block which is sent by more than 50% of my neighboring nodes. And the thing is, at the end, the one with the longest chain wins. Because if I as a miner has lot of computing resource, I can defeat all the miners in the Bitcoin network, and I go on adding lot of blocks. Then mine will be a lengthy block, and everyone at the end will synchronize with my chain. So this happens only I have lot of computing power, and this one we call 51% attack. So if I have more than 50% of hash power, entire hash power of Bitcoin, it happens in Bitcoin network. So if I have more than 50% of hash power of Bitcoin network, then I can corrupt the entire blockchain. I can, for my personal benefit, I can change the transactions, and I can generate I can go on adding new blocks with my malicious transactions. Okay. Okay, let me check, and what else I had left. We had seen on my units. All of you, did I give this link to you? This is a software you can download, Bitcoin software to be a full node. And this is a wallet. Those are interested what a wallet is. There is a wallet is which we can which will maintain our which can store or which can maintain our private and public keys. This wallet interacts with the blockchain. It will not be storing the entire blockchain copy, but it just interacts with the blockchain. So you can try open this link posted in your chat window. So everyone got this link. Yeah. So you can register. First, you can go. You can create a wallet wherein we require the wallet ID and password. For this one, you need to sign up. once you got wallet ID, you can do it later, just watch it. So this is a wallet ID and some password had created with the help of the sign up, and this is a login page wherein I will log in into my wallet. Right. So this is a wallet. In this wallet, currently I don't have any. This is a wallet wherein there are it shows what are the balances you have in your cryptocurrency, Bitcoin, Ether, Ethereum, Bitcoin Cash, Stellar, and these are the various cryptocurrencies we have. And my balance is zero balance. And if I want to send if I have some Bitcoin balance, it's like I can send some Bitcoins to some other person with the help of some address. So we have already seen the Bitcoin, how the Bitcoin address is generated from the public key. So when I want to send some Bitcoin, see, first we'll go with the request part. Request. I click the request part. So request Bitcoin. Here, this is my address in real time. This is a real-time wallet, and you can see this is my address. So there will not be having any names. This is my something like a bank account number. This is my Bitcoin address, wherein I can copy this one Bitcoin address, or even if I have the app, I can scan this one. I will get automatically. I will get this address, and this is my account number. If I want, if my friend want to send some Bitcoin to me, 15 Bitcoins, I can give this address to him with the help of mail, or maybe with the help of by messaging in the WhatsApp. I can send this address, and my friend can send some Bitcoins to this address. So this is receiving address at my end. So this address you can give in WhatsApp. The address is account number you can give to anybody. It is not a secret. And if I want to send my Bitcoin, this one is receiving. For receiving this address, Bitcoin address. But if I want to send a Bitcoin, if I have some balance, currently I don't have any balance, but if I want to send, this is the address where I can type the address of some other person, my friend, something like this one. And I can specify how many Bitcoins. So Bitcoins is like 1 Bitcoin I can send, or else I can send point up to 8 zeros I can send, something like 0, 0, 2 Bitcoins. So equivalent, this is dollars, 18.81 at current, as per current exchange rate, it's like this is the amount 0.02 I want to send. So transaction rate will be transaction fee will be deducted from this one. It will be 0.305. 0.305 will be subtracted from this one, and remaining amount will be sent to my friend. Okay, when I say continue, it's like the amount will be sent to this one. So transaction fee will be deducted from this amount. It will be 0.3075. It depends on the network that it will be changing. It will not be the same every time. And hope we are done with yeah, all the we're done.
Yeah.
Siraj sir, yes.
Yes,
we are
Naveen
done.
sir. Naveen sir, right.
Yeah, thanks all of you. If you have any doubts, you can mail me or message me.
Yes, Naveen sir, thank you very much for your very informative session. With your permission, I would like to take some questions. Shall we take some questions, sir? 1 or 2 questions. And the people, if you want to ask,
yeah, sure, sir. Yeah,
raise your hand. Then we will unmute you. You can ask questions directly to the speaker. And people, if you still want to ask the questions, you can also post the question in your chat box. And you can also try to fill the attendance link. It will be posted in chat box now itself, right? And attendance link will be active for another 20 minutes. So don't forget to fill the attendance link. It will be activate only for 20 minutes. I request M. Srikanth sir, please post the attendance link so that all the participants can fill that. And meanwhile, if any participant, if you want to ask any questions to the speaker, please raise your hand. You can raise the hand so that I can unmute you. You can directly ask a question to the speaker. Attendance link is available. Please click and fill it. Does anybody want to ask the questions? Raise your hands. Otherwise, you can also put your question in chat box.
Yes, Madhu. Is quantum computing threat to blockchain? Yeah, it's like uh, when you say quantum computing, yeah. At present, when we look at the Bitcoin blockchain, there is a, in present scenario, if we have a quantum computing, there is a threat, because in quantum computing, it's like as we seen in the previous slide, from the private key we had generated public key, right? Public to private, sorry, private to public we had generated. The reverse cannot be done. As I said, just a minute. The battery is low. Yeah. Yes. So from the private we had generated public, and I said like the reverse cannot be done. But in quantum computing, using quantum computing, the fast processing, it's like the reverse can be done. But the thing is, we have quantum resilient algorithms, which are actually they are invented by NIST, which is an international standard organization. They had requested to submit quantum resilient algorithms. There are algorithms which can resist the quantum computing, which can be used in blockchain. 3 years back, this is done, and lot of organizations all over the world, they had submitted those quantum resilient algorithms, their research to the organization, and those algorithms are being tested from the last 3 years, and in future also for around another 2 years they will be tested, and maybe in 2022 those those algorithms will be officially declared. And once they're declared, it's like the quantum computing cannot do any harm to the blockchain. And it's like those algorithms have a key length of maybe thousands clear. Currently the key length is like 256 bits or 512 bit, but in the quantum resilient algorithms, the key length is like 30,000, 40,000 bits. And in quantum resilient, there are some algorithms like SHAR's and SHAR algorithm, and the one algorithm is Grover's algorithm. In SHAR algorithm, we can reverse, we can get back the private key from the public key. But thing is, it's hard at this moment. Even Google is developing quantum computing with around qubits. I remember 50 or 150 qubits. But if you want to break blockchain, you need around 1,000 qubits, 1,000 to 1,500 qubits. But this is not possible in the near future. It takes some years. Meanwhile, blockchain will develop, and there will be quantum resilient algorithms which can defeat quantum computing. Yeah. Hope I answered your question. Can we modify the data in a block? Yeah, existing block we cannot modify, but the thing is, if you want to modify the data, you need to add as a separate record in the current block. You need to add in as a new transaction, but thing is, existing transaction you cannot modify, you cannot alter. If you alter, if a malicious node alters, the entire blockchain gets invalidated. Let me look at others. What is the starting step to invest money as a Bitcoin? Ramakrishna. I say, Ramakrishna, please don't invest amount in a Bitcoin. It's very risky because the market is very volatile. It's like in one day, the entire your money gets half. The Bitcoin cost can be in 1 or 2 days, it can become half, and in maybe yeah, you may have the other end. It's positive in 1 or 2 way. It may double, but thing is, most of the cases you cannot predict. There are some strategies like what do you say? Analysis we can do, but thing is analysis will not work. It's very volatile, and remember, Bitcoin is maintained by whales. Most of the Bitcoin, actually, Satoshi Nakamoto, he had developed this Bitcoin blockchain to be democratic, but the thing is, it is in hands of few people, millionaires, who maintain who will play with Bitcoin blockchain. If they want to increase the Bitcoin cost, they will increase. If you want to decrease, I say it's very risky. Don't invest in a Bitcoin blockchain. I say it's better to invest on lands. Lands better. Lands are at the moment, I mean, gold in future. But thing is, don't invest in cryptocurrency. It's very volatile. It's very dangerous. Very risky. Can we use cloud for storing blockchain if we don't have? We have a cloud service also, Azure and others, Microsoft Azure and others, they're providing blockchain service also. We can, we have blockchain available. And one important thing is, blockchain is not alternative to traditional databases. It cannot, at the moment, it cannot handle a lot, it cannot store a lot of data. So what we do is, a lot of data we can store in database, but thing is, we can, its hash is stored on blockchain. It's whatever data we stored in blockchain. For example, if we have 1,000 records, 1,000 records hash can be stored in the blockchain. And when we retrieve data from the blockchain, we'll check with its hash. If it is, say, we will retrieve the data, record from the blockchain. Sorry, record from the database, we will hash it, and we will check with the hash, its hash which is previously stored on the blockchain. If they are same, the data is not tampered. In this way we can use, but thing is, it's not completely altered, because we cannot completely an alternative to the existing database. Let me check.
Sira sir?
Yes, sir.
Please give the information for tomorrow's session, sir.
Small information for tomorrow's participants. So I hope today's session is very informative, and a lot of information is also coming in tomorrow's session, because we have 2 more new speakers. One is from Oracle Senior Software Engineer, another is from a senior faculty member from Bhakdevi College. So I think you will get lot of knowledge tomorrow also. So don't forget logging in tomorrow, same time, 10 to 12. And login credentials, you will get the mail today evening. And don't forget to fill link. So your attendance will be considered for giving the certificate. So tomorrow, end of the session, along with feedback form, you will get the certificate immediately. So if still anybody want to ask the question, you can ask to the speaker.
Yeah, proof of stake. Can you explain about proof of stake?
Yes, sir. This question is very repeated question.
Yeah, it's an algorithm which is used by Ethereum, and this is based on, it's not computing power. It's based on the what are the number of coins. Ether we call as ether. The number of coins you stake, you store, and then you participate in the mining, and it depends on the coin's age also. Let's repeat it. Yeah, I think no more questions.
They are busy in filling attendance form, I think, sir. So anyhow, nice session, sir.
Okay.
What you have shown on you, we got good knowledge.
Thanks
So,
all of you for being concentrating, being patient for the entire session, 2-hour session. Thanks. I thank all of you, one and all.
thank you very much, sir.
Thank you very much. Thank you,
Anjali
Nayan,
sir, with your permission, I would like to terminate the meeting. Anjali sir, with your permission, I want to terminate the meeting. Is it okay, sir?
Okay, fine. Fine with me.
Right, sir. Thank you.